Hello.
Monaco here.
Milks.
In our
We're also here.
Hitting you up with boot camp lecture numero 4.
4.
It's magic.
Mr.
Measuring tools and accuracy. These things are not magic. They're actually very simple things that we need to know how to use, because not so much rulers this year, but definitely graduated cylinders and balances. And the reason why we're putting rulers in here is because a graduated cylinder
It's
is
like
a ruler
for liquid.
for liquids.
Oh, wait, I think there's a learning target. Getting better at this, man. Getting better at this. So you, at the end of this video, you will be able to use measuring tools like graduated cylinders, digital balances, and interpret correct units. So let's get started. Oh, there's a ruler.
There's a ruler. The cool thing about rulers is that they're used to measure length.
Yes.
I don't know if you ever knew that. No?
Well, now you formally do. Okay?
The important thing we need to say is that if you're using a ruler and your measurement falls between two of those little lines on the ruler,
So, like,
right? This looks like a ruler, right? So like if you are measuring an object that falls in between the two little lines, you have to like estimate where that result really was.
and I'm saying that's a little over half between those two lines.
So that has to be reflected in the number you record down at the end of the day.
Whoopsies.
Graduated cylinders,
Same thing.
except
Except for now I'm dealing with volume of liquid, and it's got a little ruler on the side.
Mhm.
And I'm going to be able to read it. And there's another piece that's going to teach us how to read that in a minute, so we'll get into it then.
Mhm.
But then I can do the exact same thing. If I'm in between two dashes, I can estimate that last digit. And we're going to get into that later on. It's going to come back into play with what we call sig figs.
And digital balances are probably really easy because they're used to measure mass, and they do the estimating of the last digit for you digitally.
Yeah, you
That last decimal place you might see bouncing around a little bit and get frustrated by it. Don't. Because
That's
that's
the
the
piece that's-
imaginary number. It's like 4.67, or maybe it's 8, or maybe it's 6.
These things are sensitive enough that when you lean on the table, it could change. Somebody's breathing heavy, honestly, it could change.
Right.
Temperature changes, it can
So-
change. That last number isn't the
Don't get
most
obsessed with
critical
it. The last number is the least significant digit.
Sure. So,
When you read a graduated cylinder, we always read the bottom of the meniscus.
so right like that. And
Yeah.
you see it's on the correct line. It's at the bottom piece of the arc.
And you want to make sure your eyes are level, right? The best way to maybe do that is actually to put it on a tabletop and get down low and look across it, okay?
Right.
You don't want to be like this, because guess what? Your hands are shaky,
Right.
the water's moving around.
And more importantly, are you holding it exactly level? You hold it like this, it changes where it touches the side.
Exactly. That's why we had to put this in there, because we do a lot of graduated cylinder reading.
Yes, we do. And then we can figure out this thing called volume by displacement.
Right.
So if I have an irregular object, I can drop it into a graduated cylinder. Here's an
Like
irregular
this.
object.
It's
I can't
got a
just
weird
measure-
shape.
I can't just measure length and sides and widths on this thing, right?
No.
But if I put it into my graduated cylinder, first I say, well, what's the initial volume of water in my graduated cylinder?
Where did it start before I put the thing in?
Drop it in. Now what's my new?
So it went from here up to here,
The difference is the volume of this thing.
and that's what this equation's all about. It's technically Archimedes' principle.
I can't spell that. You might be able
Yeah. These are the type of sample problems. I'll read it, you write it, okay?
Go.
So for example, we have a graduated cylinder that already has 16 and a half milliliters of water in
Ooh, already has. Is that initial or final?
it. Initial.
Got you.
Okay. It doesn't say already has 16 to 5 milliliters in it, but you have to assume that based upon the problem.
Yep.
We add a marble and the water in the volume rises up to 22.4 mil.
Ooh, that rises to tells me.
Final volume.
Got you.
So if I have to figure out how much the marble's volume was, I need to find the difference between those two numbers. So 22.4 minus 16.5. Ooh, he's doing the longhand math. Let's see if he can do it.
Oh, you really want to do this?
14
So that's a 9,
Yup.
and then that goes to a 1, and that's a
5.
5.9.
5.9 milliliters. Exactly. Mental math.
Right on the spot.
Exactly.
Ooh.
But that's what we're talking about. You got to have some mental math skills to get this stuff
Hey,
done quickly.
okay.
You did great.
Thanks.
Good job.
Thanks.
So what do we got next here?
Oh, balance.
Using the balance.
Using the balance. So, direct mass of an object is literally tear the thing so the balance says 0,
Mm-hmm.
put the object on, and how much mass is there?
Read the number.
Is it
that comes
36 grams or 36.4 grams? Great.
up. Just read the number. Now, indirect masses comes into play when you have to put a certain amount of material into a beaker or a flask.
Right. Or if we're dealing with powders and stuff, it's
Right.
a little bit different.
Like, I need 10 grams of powder in this jar. Well, you have to do a slightly different technique, but it's very simple.
Very similar.
Tear the balance like normal, and you got to record the mass of the empty container.
Right.
So we
Maybe
got to
it's
know how much this coffee cup weighs without anything in it
first.
first.
Then I can put the stuff in it and record the mass of the two together.
Mm-hmm.
And then if I know those two masses,
Right.
I can subtract.
Right, to find the container and the sample separately. So it's like if the mass started here as the container and it went up to here with the sample in it, that means the change in there was the sample's mass, just like the graduated cylinder.
A displacement. Yep. Very much like the same thing with displacement. Okay.
There you go.
Good. That's how we do that.
And another example, you want to do this? You were good at that mental
Oh,
math.
here we go.
Oh, maybe find a calculator for this one.
Okay.
A dish is placed on a digital balance. It has a mass of 93.4.
There it is.
And in this case, we call out the mass of the dish,
There you go.
93.4.
Nice. That's beautiful. Okay.
And then a powdered chemical is added to the dish, and the final mass is recorded as 105.7. So the mass of the dish and the powder is 105.7. How much was the mass of the powder? So
Cancel these
105.7
out somehow. How
Yeah,
to cancel it
yeah,
out
yeah.
is to do the
105.7
105.7 minus
93.4. 7 minus 4 is 3,
Who's doing this mental math here?
2, 1. 3, 2, 1. And I think that's it for this video.
Oh, let's check.
No, accuracy and
And
precision.
this is actually the heart of the matter for the
I
whole
thought that would
video.
have been perfect.
So if
3,
you- if
2,
you-
1, done.
You
But
like that, right?
nah.
If you zoned out a minute ago, listen now carefully. Because here, a whole new learning target for this space. Ready?
Tell the difference between accuracy and precision in a measurement. It's
You need to
very
be able to
simple.
do it. So let's define them. Accuracy, the closeness to the desired value. Example.
Hey, didn't we do this in our vocabularies?
Did and isn't vocabulary important?
Yes, it is.
See? So how close were we to the target? If the target was the bullseye, did I get closer?
Right.
Precision's different.
How repeatable your results are. Consistency. Okay, everybody can throw a dart and get a bullseye once, but you're not getting on the pro dart circuit unless you can hit the bullseye all the time.
Right.
Okay.
Okay.
Period.
So then we just need to know now,
In this
looking
case,
at this picture.
Cheryl, Cynthia, Carmen, Cassie, who's accurate?
Well, accurate by definition is close to the bullseye.
So who's close to the bullseye? I'm going to do it in red. Accurate is red.
Carmen.
Carmen is accurate. And out of the other ones, I mean, Cynthia's almost accurate. She's got it.
Cynthia is close, yeah, but
Yeah,
she's not
right.
as precise.
Very good.
Cassie's very precise.
Take precise. I'll go green.
So
And
Cassie,
the grouping is tight.
yeah, Cassie and Carmen are precise.
Yeah, the grouping's even tighter.
But Carmen is both precise and accurate.
Oh, let's go blue.
So accurate and precise is Carmen. Cynthia is kind of everywhere. Cheryl is
All over the road.
wow, all over the place. So
Yeah, that's like drunk driving.
yeah, don't do that. Yeah, don't. Or you know what? I don't want to pick on Cheryl. Maybe Cheryl's never thrown darts before.
Could
Okay.
be, but she needs a lot of practice to get either accurate or precise because she ain't either.
No.
She ain't got none of that going on.
Nope. Okay. So, see what else we got here. Percent error. Not much time. Human error. I make a mistake reading my instrument.
Yes.
Simple enough.
Instrument error is inherent, and you'll see it in the fine print of the actual graduated cylinder, plus or minus 0.1 milliliter.
These devices can only be so accurate,
Yes.
and they say how accurate they can be.
The measured value is the value I actually get when I do the measurement.
Right. So your mass, your volume, your
Yep.
length. The accepted value is what you should have gotten if you measured it correctly. And so we do a percent error, which is a simple calculation.
Okay,
Right.
I'll do it.
And we don't have much time, so we got to get through this quick.
Go.
So we measure the mass of in sugar in a can of Coke to be 39 grams. So that's
That's
our
the
measured
measured.
value. The
Gotcha.
accepted value is 40 grams.
Okay.
So to do the calculation, we take
Plug and
measured
chug.
39 minus 40 and divide that by 40.
Okay,
and
so that's
multiply it.
basically minus 1 over 40.
And then you multiply that result by
Times
100.
Okay, I don't know
So
what-
whatever that is in percentage is how close you were to the right answer.
And don't be upset that it's negative. It just means your measured value was lower than the accepted, not higher.
Okay, so this was actually your first very long video, and not sorry.
No, and we're out though.
See ya. Click the button and it's